Okay, so your first midterm exam is coming up on Friday. I've sent out on the website last year's midterm exam, so you can get a sense for the types of problems you can expect to see, the number of problems, the format, and so on. So what I want to do today is just go over with you the key concepts that I'm looking to see from all of you when you take your exam. So far in class, in my view, we've covered three really big ideas, three sort of analysis problem solving type ideas. One is working in problems that are sort of viscous type problems. One is working with surface tension, understanding how to express surface tension as a force. Working in problems involving changes in hydrostatic pressure. Those present themselves often as manometer type problems. Okay? So if you look at your sample exam, you'll see three problems. One which involves a viscous stress, one which involves surface tension, and one which involves hydrostatic pressure. You'll also see a number of short answer questions where I get at a lot of other issues which I want to encourage you to learn and master, and those issues are listed here. So what are those complementary issues that are important to know? Always know your dimensions. We need to understand this idea of vapor pressure because it relates to boiling, it relates to cavitation. The idea that some fluids can be assumed to be incompressible, others are compressible. The idea of a continuum, we have a video on that. We need to be able to visualize surfaces and the intersection of surfaces. That's really important for looking at surface tension problems and also for looking at pressure problems when we move through vertical systems and we see how the pressure changes vertically. Recognizing those surfaces is important. Key fluid properties like density, specific gravity, or specific gravity, specific weight, ideal gas law, understanding a Newtonian fluid versus a non-Newtonian fluid, understanding the idea of dynamic viscosity versus kinematic viscosity, and of course the ability to think in 3D. So one other idea which I haven't listed here, which is also important, is the difference between absolute and gauge pressure. So we'll write that down. Okay, so I think that's a good synopsis of the big ideas that we're trying to get at here, these problem-solving areas, and also this other knowledge that you want to have in your toolkit to be able to go after these big problems. I want to wrap up with just another review of Greek letters, kind of key fluid properties, and how to write these letters. So we have rho, which is the fluid density. We have gamma, right, which is equal to rho times g, and that's the specific weight. We have mu, which is the dynamic viscosity. We have nu, which is the dynamic viscosity divided by the fluid density. We've got tau representing shear stress, which can be modeled with Newton's law for viscous fluid as mu du dy. And we've got sigma as our surface tension, and we always remember that the dimensions of sigma are force per length, unlike a stress, which has units of force per area. So rho, gamma, mu, nu, tau, sigma, probably forgetting something, but that covers a lot of the important ones.